Here we are. It is containers from the couch. How y'all doing?
Doing great. How about you, Eric?
Good. This is what I said. How y'all doing? You both went. So I'm glad you're good. I'm glad you're here. I'm excited. Ollie, how are you, sir?
I'm good. I'm good. Excited to talk about this. This is a good topic. This is an exciting one to do.
Yeah, it really is. If you're not familiar, we just had a new release today, or not today, this week. I think it went out Tuesday, right?
Yep.
And it's. I'll let you say it, Ollie. You guys can say it together or something, but tell them what's coming, Ollie.
Yeah, absolutely. So this live stream, we're diving into Amazon ECS managed instances. This is a new compute offering for Amazon ECS.
Yeah, it's super exciting. I want you to know that we had serverless office hours on Tuesday, and I mentioned this.
Oh,
That's right. I mentioned the containers when we were talking about because I actually use a container for agents, and I'm going to be moving it over to managed instances to take advantage of some of the things we talk about. So I want to take a moment real quick here. We kind of jumped the gun, but Abhishek, let's start with you. Tell us who you are, why this matters to you, and what you do here at AWS.
I can go. So my name is Abhishek Nautiyal. I am a product manager on the ECS Fargate team. Been on the team for about 4 years now. I focus on aspects like capacity management, auto scaling, performance, and other things. And over the last year or so, we've been working very hard on launching managed instances, and I'm really excited to talk about this feature today.
Really good job on this. This is really cool. Ollie, who are you? What do you do?
yeah. So, hey, I'm Ollie Pomeroy. I'm a solution architect here at AWS, but I specialize in containers. I specialize in Amazon ECS, AWS Fargate. Yeah, been on the stream a few times. They sort of come on to talk about what's new every month or so.
Nice. Well, and if you're not familiar, my name is Eric Johnson. I'm not always on Containers of the Couch. Just when we talk about ECS, I generally come on and talk about it as a serverless container on Fargate and different things like that. I am a developer advocate, part of the DevX team, and absolutely love serverless, and I love serverless containers. A year ago, I couldn't even spell ECS. But with Ollie's help, that joke kills every time. I really do think it does. With Ollie's help, I have become more familiar with it. I've been doing a lot with it. I have been building on it and absolutely love it. And to me, this is a really cool, feature because I mean it's a pretty big one too. And so Ollie, if you want to kind of jump in, tell what are managed instances.
Yeah, I can go on this one, and then I'll probably hand it over to Abhishek a little bit to provide some of the background. But yeah, so this is a right now today. If you want to run a workload on Amazon ECS, you make a decision, you make a choice. You either run that workload on EC2 instances, and you get some great flexibility of picking the right instance types you want. You can use all the various AWS pricing options. You can go and pick your favorite AMI or your AMI. But those operating systems, those instances, they're yours to manage. Or you can go to the other way, and you can go on the Fargate and the serverless container side, as you mentioned before. But when you go down that path, you pass off all of the infrastructure management over to AWS. But we've kind of found over the years that customers are asking us for something a little bit in the middle. They want a managed experience, but also the ability to kind of customize their compute a little bit.
Yeah.
So this is what ECS managed instances is. It's a brand new compute data plane offering sitting in between Fargate and EC2, and it provides that managed experience, but with the flexibility.
Amazing. If you're watching on this, let us know where you're watching from. If you post in the comments, we'd love to see where people are watching from. Who are you? What do you do? And Abhishek, I'm going to kind of turn it over to you now. You've been working on this. It's more than just, hey, I can now run GPUs.
Yes.
What are some of the things that you went, yeah, that's going to hit really hard? What are some of the things that you're most excited about?
Yep. And I'll maybe take 30 seconds, Eric, just to
Yeah,
kind of give
yeah.
a little bit more context. So for anyone joining us who's struggling with the spelling of ECS like Eric was in the past, just to give context, ECS is AWS's fully managed native container solution. And it is ECS is the solution that customers overwhelmingly, like the new to AWS container customers, over 65% of customers we see start on ECS. So it sees massive adoption. And over 78% of those customers actually start with the serverless compute on Fargate, which is the easiest way to run containers on AWS. So just to give a bit of context on why we are here, and like Ollie was alluding to before, what's ECS supports like the entire spectrum of compute options, right, from on-prem to like Outpost to local zones. But ultimately, what boils down for customers is running on either EC2, which is majorly self-managed compute, or running on the serverless compute engine, which is Fargate, where all customers need to think about is their applications without having to reason about any sort of infrastructure management, scaling, provisioning of servers, patching, compliance, so on and so forth. What we've seen over the years is customers really love the Fargate experience and its simplicity and like hands-off, no infrastructure management. But being a serverless platform and being a serverless compute engine, rather, there is limited ability for customers to do any sort of customization, which could be things like if I want to run a particular application that requires higher network bandwidth kind of instances, or if I want to use the latest and greatest instances that EC2 or AWS has launched. An example would be fractional GPUs that were launched very recently. Also, if customers wanted more control over running privileged containers or elevated privileges like eBPF probes, for example, for monitoring and security solutions. Some of these were constrained in the Fargate world, because Fargate essentially is like you don't have to think about the compute, reason about the compute at all. Like the compute is within AWS, and the contract, so to speak, with customers is customers focus just on their containers and tasks. On the other side of the spectrum, and we saw customers using EC2 for these kind of scenarios or use cases. On the EC2 side, we kept hearing from customers that they wanted a simplicity similar to Fargate in
Right.
because where ECS and where AWS really excels at is all of the best practices that we have learned over the years on operating at massive scale and wanting to bring that to a wider range of workloads. And in the EC2 world, it meant not only managing more things for customers, but also giving better scale, performance, cost optimization capabilities. And all of this kind of germinated this idea that we did not want customers to think about EC2 and Fargate as kind of like a trade-off decision. And we wanted to bring customers the best of both worlds, and which is what germinated this idea of launching and building managed instances. So what managed instances does is by default, it works very similarly to Fargate, and Ollie will dive into the experience in just a little bit. But the default experience, we have used learnings both from operating Fargate and EC2. So by default, it is very similar to the Fargate experience. You just write your tasks. You just point them to a managed instances capacity provider, and they just run. You don't have to do any sort of customization. But if you wanted more customization, for example, if you wanted to run GPU workloads, you can tell us to launch. You can instruct the capacity provider to launch either a specific GPU instance or give it attributes like accelerator, for example, based on which we will select the right type of instance that maps to the workload. Additionally, customers can have access to privileged capabilities and run probes requiring elevated privileges. And finally, what we've also built is, and I know I'm talking about multiple features here, and
You're still on the thunder here, buddy.
I was going to say, man, killed it all in the first 5 minutes.
I said 30 seconds.
I'm shocked excited. That's where it's at. I mean, we're excited about this.
As you can see, very excited to talk about the features. But the final thing I would conclude with is we've also built a cost optimizer and task placement, entirely new way to auto scale tasks and instances for managed instances. Again, taking learnings from some of the features that AWS has launched over the years, this one in particular being learnings from Carpenter. So we do similar amount of cost optimization and consolidation across instances. So yeah.
Nice.
Lots in there. Lots in there.
And that's our show for today. Everybody have a good one.
Yep.
Just kidding. So I'm going to pause for a second here real quick. If you hadn't noticed, I'm having all kinds of technical difficulties. I don't know why. I've got rock solid internet. I'm not sure what's going on. So if I disappear, it's not because I don't love this feature or what's going on. I'm not sure what's going on. I seem to be working now though. So Ollie, if I drop, you got to shave your head, cut off your thumbs, and start talking. So you know how it goes. So, we'll figure this out. So Ollie, you ready to share your screen?
Yeah. Absolutely.
All right, let's bring that up here. Okay.
So just a couple of things I wanted to say before I jump into the demo. So we're going to do all sorts of demos. I talk about some of the things that Abhishek just introduced, provide some demos on how to get started. As Eric mentioned, managed instances went generally available on Tuesday. So September 30th, this went generally available. It should be there for people to create and use, and it's available in 6 instances at launch.
6 regions or
regions, yeah.
There we go. Okay,
6 regions.
6 instances. Those are already taken. You got to get in line. No, it's just 6, right? 6 regions.
Yeah, and then the rest coming soon. So there's a few different ways to get started. Let's take a look in the console, see what it looks like, and then we'll jump out to some CLI and some CloudFormation as well.
Sounds great. So, CloudFormation. Sam, we'll call it Sam. All right.
We'll call it Sam. We'll do our best. So this is the ECS console for those that haven't seen it before. I have a couple of existing clusters, but just to kind of show how you would interact with managed instances, you do so through the capacity provider tier. So capacity providers, it's like a way for you to abstract the different compute options in ECS. So you can say, like, Fargate can be capacity providers, auto-scaling groups can be capacity providers, and now managed instances are capacity providers. And then when you go to deploy a workload, you say which capacity provider you want that workload to run on. So now when you create a cluster, inside of here, there's a whole new managed instances set of options for capacity providers. And as Abhishek mentioned, you can just use the default managed instance capacity provider and you're good. Like, you don't have to worry about much else. We'll decide which instance types to use. These will be like general purpose instance types. And you kind of get like a Fargate-like experience. You don't have to think about instance types. You don't have to think about managing operating systems, AMIs, or anything like that.
All right, so let me ask a question here, and you may say, "Oh, yeah, you didn't. I didn't get very far, Eric." Okay, so but my question here, and if you want to push me off on this and say, "Hey, we'll talk about that in a little bit," but if I do Fargate and I use the ECS default, the Fargate and managed instances, what's the difference between doing that and then just choosing Fargate only?
Yeah, so you can choose Fargate only. Then the only capacity providers in your cluster will be the Fargate capacity providers. So every ECS cluster that you create can just be a Fargate only cluster. That's absolutely fine, and like that's available. But if you want to add additional capacity providers, maybe that is managed instances, or maybe that is auto-scaling groups or self-managed, you can click on it. And you don't have to make this decision at this point, right? You can decide afterwards, like, oh, hey, I want to add a managed instances capacity provider to my cluster, or later on in the demo, I'm going to start adding them into like existing environments and migrating workloads and stuff like that. So it's not a one-time deal here.
Yeah, and if you have an existing cluster, you can add a managed instances capacity provider to the same to an existing cluster.
Okay, so you can. So I see what you're saying. So this is if I'm planning on having more than one kind of capacity provider, then it makes sense to do that middle one, and then I can say, look, I'm for this one, I just want to use ECS default, recommend it, that handles it. But then I may add some more coming up. We have another question. This one's not from me because this is an office hours type thing. We try to take questions and answer them as best we can here. It says, hello, everyone. I have a question. Is there a native tool in ECS managed instance that supports horizontal node scaling, similar to how Carpenter or Cluster Autoscaler work in ECS?
Yes, and this is what I was referring to earlier. So we have built a new cluster autoscaler specifically for managed instances. The way it works, you can think of it very similar to Carpenter. So ECS scheduler is the component that's responsible for scheduling new tasks, and the autoscaler works with the scheduler. It looks at the queue of pending tasks and it launches instances just in time. And here, like what we are seeing is if you use the default option, by default, the autoscaler will determine cost optimal instances, but those instances are going to be general purpose, and it's a decision that we took because we did not want to, by default, for example, launch an expensive like a GPU instance. So by default, it chooses a general purpose instance. You can give it your own custom instances, and it'll only launch those set of instances. So yeah, like similar.
Great.
Yeah.
Ollie, are we just stealing your thunder left and right? We are, aren't we?
It's all good. I finished the demo real quick.
So nice. I'd be like, stop talking. I'm gonna say this stuff. Go ahead. We got another question that came in, but we'll come to it a little bit. So I do see Mohammed, and we'll get to that in a little bit. I'm gonna let Ollie talk for a little bit.
All right.
And then we'll just interrupt him and we'll go to your questions. So
no, that's good. So what I'm going to do is I'm going to create a brand new cluster and I'm going to create a capacity provider. And Eric said it has to be CloudFormation so he can get his.
I didn't say it has to. I just said it had to be. We should show it. Yes. Okay.
So here we go. So we got a CloudFormation template. We're going to create a new cluster, and we're going to create a new capacity provider. Now, there's some interesting things about the capacity provider. First thing it's going to say, it's a managed instances capacity provider. And we have to pass in 2 IAM roles to a managed instance capacity provider. The first one is an infrastructure role. This is giving the ECS control plane permission to create instances in your account. Now, this is one of the big differences between managed instances and Fargate, is that in Fargate, the instances live in an AWS account. You don't see them. But in managed instances, the EC2s that we'll create live in your account. And this role right here gives the control plane the permission to make those API calls. The second, a bit further down, is another IAM role. Actually, this is an instance profile. And for those that have used EC2 instances before, an instance profile is a role that's attached to the instance so it can make AWS API calls. And so this is a role that's attached to the instance so that the ECS agent that runs on that instance can communicate back to the control plane. Those are the only 2 prerequisites inside of a capacity provider. Apart from that, I've put in some subnets where I want my instances to run. And I've also put a tag. I put Team Squirrels as my tag, and we'll see why that's interesting later on.
Nice. I know.
So let's all right. Let's provision this and let's see what happens. I'm just gonna jump to my cheat sheet so I don't spell anything wrong, and I'm just gonna update my stack, and that'll go away and create my environment. I will say a few things I didn't see below in this template as well. I actually have a load balancer configured. I have a task definition, and I have a service. So as well as creating the cluster, I am deploying a workload. but I'll talk through that workload in a little bit. We'll talk about the infrastructure first. So quick look in here, we now see the managed instances cluster, or MI cluster. And then under infrastructure, I now have my default capacity provider, which was the one that I just created. As Abhishek mentioned, right now, like the managed instances is a cluster autoscaler at the same time. So right now we have no instances in the environment, but as that workload starts to scale up, we'll react to those pending tasks. Just clicking into the capacity provider, not too much to see, but you can see that the IAM roles that I had provisioned is there, and as well as the network configuration for where I want those instances to run. Jumping back a little bit, you should see that my services should also be coming up. It's a service that has 3 tasks, so I should now have 3 pending tasks. And this will kind of sit in the queue, and the managed instances scheduler will now kick in and say, right, I need some compute to run those tasks. Do I have available capacity in the cluster? We've seen that there's no instances, so the answer to that is no. And then it will go off and it will make an EC2 Fleet API call to go and provision some capacity. So there's no autoscaling groups here. This is straight from the ECS control plane, provisioning instances through the EC2 APIs. That's gone off, and you can see pretty quickly I now have these tasks running, and that was pretty quick to start instances from scratch and get the task running on there. And if you scroll over, you can see that they've got an instance ID where they're actually running. Some interesting things, if I go back to the cluster and I go back on infrastructure, you can see that I now have my 3 instances. And the first question might be, well, why do I have 3 instances? And the answer to that is because by default, we will try and spread your workload across availability zones for resilience. I had 3 subnets inside of my capacity provider, 1 in each AZ. So now I have 3 instances, 1 in each AZ, and it has distributed my tasks across them. So without having to do very much and think very much, I have a resilient service. It's across my AZ. And then scrolling over, you can actually see the instance type that was chosen. In this case, was an M7A medium. So as Abhishek mentioned, the default capacity provider is just doing general purpose compute instances. And we've picked, we tried to like right size that instance. We tried to say, what is the most cost efficient instance to run my task? And if you look inside of my tasks, they've been, when I created them, I gave them a size of 1 vCPU and 2 gig of memory. And so what it's done is it's tried to find the closest instance to match it. And so it's actually find a 1 vCPU and a 4 GB instance. Hence why I've got a bit of memory left over, but no CPU. So yeah, that's gone from nothing to a brand new cluster, brand new capacity provider with a workload running on it.
All right. So can I ask you a couple of questions?
Absolutely. Go for it.
All right. So we had the question earlier talking about the node scaling similar. So the follow-up on that was, is there any similar with auto mode? Do we have anything similar to auto mode?
Yeah, absolutely. So yeah, so it has a lot of features that are quite similar. So yes, we're provisioning instances through the EC2 Fleet API. Those instances are managed for you the same way they are in auto mode.
Okay.
There is a lot of similarities there from that like compute data plane perspective, but then at the end of the day, this is ECS with its managed control plane and its tasks.
Okay. So the follow-up to that is this one. I like this access instance we talked about. Observability for managed instances. You know, how can you access instances? And I think Abhishek, you had alluded to this earlier. So if you want to take this for a second, and then I think if we have time, we're even going to show this, but we'll see. Yeah.
Yeah. So one of the things with what Ollie just demoed in terms of setting the capacity provider up. And it's also common with to the EKS auto mode question. So the way this works under the hood is it's a managed instances capability wherein when you are setting up the infrastructure role, you're giving AWS the permissions to fully manage these instances. At the same time, you are acquiescing control to AWS in the sense that for these instances that are launched by ECS managed instances, and I would say even for EKS auto mode, you cannot terminate these instances, for example, or you cannot SSH into these instances. Although the instances are launched in your account, AWS fully manages all aspects of these instances. And observability wise, it's pretty similar. Like these instances are still your EC2 instances. You can use your existing tooling to track utilization, like for tracking metrics and so on, to check on like cost allocation, cost optimization, and so on. Like all of that behaves just like a normal EC2 instance for them. Ollie, I don't know if you wanna show some of that, and
yeah, absolutely. You stole my next demo again, man. It's all good. So yeah, if I switch to the
segue, Ollie, it's a segue.
Sorry, I just get precious. I get excited. I want to show it.
Go ahead.
No. So yeah, so if I look at the EC2 instances, as Abhishek mentioned, right? These are now live in your customer's account. You can see them like you can't with Fargate, but you're restricted from kind of accessing them. So if I try to just click on instance state and terminate it, you won't be able to. Like these are managed instance. You can't do it. That should have a nice big red error message. Maybe there we go. You can't go away and terminate it. This is
a nice error message.
Yep, I can't actually clear it. Sorry, I'm zoomed in too much. I can't get to the X. There we go.
There you go.
So that's there, but it is there for you to see. You'll notice before when I was creating the capacity provider, I gave it a tag of team squirrels. That tag is now propagated down onto the instance. So if I look at the instance, you can see that we put some tags on here to say, well, this is a managed instance. We can see that it's attached to an ECS cluster, but we can also like put our custom tags on here as well. So if this was like part of a shared platform and you wanted to go back and do like cost allocation on like which team has which instances and stuff like that, that's all available for you here as well. And then a little bit, as Abhishek mentioned, these are EC2 instances, so they will be having or generating various metrics. These are also being reported back into CloudWatch metrics, so you can see the default set of EC2 metrics as well. And you can choose whether you want to have basic or detailed, basic being data points every 5 minutes, detailed being data points every minute, but you can get the metrics you'd expect from these two instances there.
Nice. All right. So I know you have another demo you're going to do, and maybe this leads into it. Don't laugh at me. You haven't heard the question. And so I think this is going to lead into it. So I'm actually going to, Leandro, I know we have your question here, and I'm going to come back to that in a moment, but I'm going to continue with Mohammed's question. He said, do you have support for both, for mode both as EC2 or Fargate? Can you mix and match?
So you can absolutely mix and match. So you can mix and match in an ECS service has to be attached to only one. You couldn't have an ECS service that's distributed across Fargate and managed instances, but you could have them both in a cluster. You could have some services on Fargate, some services on managed instances, or some services on self-managed EC2s, all in the same cluster. That's absolutely supported. So you can kind of decide, depending on what the workload is, and where you want it to run.
So you get a multi-capacity. I just want to say this because it makes me sound smart. Multi-capacity providers assigned to one cluster.
Totally. And this is a bit of a loaded question because it says support for both EC2 or Fargate. I could interpret this question also as if you have services running on EC2 or Fargate, you can easily move those services to use managed instances. So it's as simple as doing update service and pointing it to a managed instances capacity provider. This is a launch we actually did a few months back, wherein you can easily update a capacity provider of any of the services.
Okay, cool. All righty. So here's one that might be a little harder. So I'm going to ask this question, see what y'all think. It says, how does ECS managed instances handle the situation when the current EC2 instance does not have enough resources to schedule new tasks? Does the scaling need to be done manually, or is there an automatic mechanism based on specific metrics? Yeah. I'm not answering it. One of you two have to.
I can take that.
I didn't know if you were waiting for me. I was like, I don't know. So, go ahead.
So like Ollie just demonstrated, when he was launching new tasks, there was no existing capacity. So managed instances found that, hey, like there are these 3 tasks. These need to be spread across 3 availability zones. So therefore it launched 3 new instances. Now what happens is if we launched one more task and the instances we saw that the CPU was fully utilized, what will happen is it will try to first see that, do I have existing instances? And if not, it will launch a new instance. But if there is space on existing instances, it will not launch a new instance. One of the ways that you can control this behavior is, for example, if you want to use larger instance sizes, and if you know, for example, that you're going to be deploying, let's say like 100 tasks, and you know that my tasks are require only 1 vCPU. So at peak capacity, I need 100 vCPU. So instead of the default behavior, which might choose an instance based on the timing of the task launches, you could launch, you could specify, you could give us a specification to only launch like a 24XL, like an M7 24XL instance, for example, which would then like hold most of these, like 96 vCPUs or something like the max. So it'll hold most of these instances. So these are some of the controls that you have to guide the scaling behavior. One good thing with this sort of a setup, if you want to bias towards using larger instances, is you get the benefits of on-instance caching because subsequent task launches will not require us to provision new instances. Container images will be cached on an existing instance. So you get a much faster performance that you would see, for example, maybe on Fargate, which is launching new instances every time, and also on ECS, EC2, because the autoscaler now is doing just-in-time and very fast autoscaling.
That's super cool. See, this is where I'm learning still on ECS, because I know, you asked me that in a Lambda function, I would, but I didn't realize that. So I'm going to repeat what you said just to make sure I'm understanding. So this makes sense to do the math and figure out, okay, if I'm going to have, if I know I'm going to need 100 vCPUs, then it makes more sense to do a big, mamma jamma one. That's a technical term. I'll explain to you later. Big mamma jamma machine that has a ton of vCPUs that I can start taking advantage of, and it'll cache that so that I don't have to go and redo that. So it's very fast launching. Okay, very cool. We have a lurker. I'm just giving you all this heads up. We have a lurker, Mr. Randall Hunt. Great to see Randall from Kalent. His question is, what's the rough % pricing premium for managed? Is that something we can answer?
So the pricing is published. Ollie, if you could maybe share the pricing page. So you can look up pricing. The way pricing works is there is a management fee in addition to the EC2 instance price. And you can look at what the management fee is per instance type. I think the way that we would want customers to reason about pricing is think of it in terms of total your like TCO savings, like total cost of operations, right? Like not just of the pure compute, but all of the amount of costs that are being saved in order to not like do infrastructure management, scaling, patching, and so on. And the second thing I would say from a cost perspective is the autoscaler that we have built will do cost optimization over time of two specific aspects. One is where it will terminate any or drain down any idle instances that do not have any tasks running on them. And also it will try to launch more cost optimal instances when it notices that your instances are underutilized. So there is no need for your active monitoring of utilization. This is all being done by default by managed instances.
Excellent. Very cool. Randall, great to hear from you. It's good. It's always good to see you. Thanks for asking that. Okay. So I posted that link. Ollie posted the pricing link on YouTube, and I moved it over to LinkedIn as well. So Ollie, I'm going to be quiet for a minute and let you continue on the demos. We do have questions come in. This is a hot topic. So questions are coming in. So I'm going to wait till the most inopportune time, and then I'll interrupt you again. So.
Got it. There's a few things I want to show that just we just talked about. I just want to show in action. So
yeah,
first thing I was going to show that scale out. So we mentioned right now we have free tasks, we have free container instances, but what happens if we scaled up? So if I updated the task at the service, and instead of having 3 of them, like I went mad and was like, hey, I want 100 tasks. We can take a look and see what happens. And there's a slight difference here between managed instances and Fargate, and Abhishek talked about it, that managed instances is multitask. So we can put multiple tasks onto those instances and bin pack them to drive up the utilization. So I wouldn't expect to see those like medium instances every single time now. Instead, I'll start to see fewer instances, larger ones that can then run multiple tasks. All while at the same time distributed across availability zones.
Okay. And those are going to be more cost effective and efficient.
Right. Very so cool. So I've just spun up my 100 tasks. That'll not take long now to get going. And if I take a look at the infrastructure, you should see we'll start to scale out. We're now on, what are we on? 13 instances, so a few more. But if I scroll over, we're now starting to see some of the larger instances, right? Some 2x's, some 8x's, and they'll start to run multiple tasks, still distributed across availability zones, but we'll bin pack those for cost. So that'll go away and do its thing. And yeah, there you go. You can see there's 28 on that one, 26, etc. And so we are distributing across. And at the same time, as Abhishek mentioned, the managed instances is constantly like taking a look at your environment and seeing if we can consolidate them as well. So as we start these tasks then start to scale back in, if these instances look underutilized, we'll start to move some workloads around and consolidate. So really, like not just provisioning, we're also doing cost optimizing as we consolidate.
That is very cool.
Indeed. And so a few other things I wanted to show. So we talked about like how do you get a workload to managed instances. So I'm just going to switch over here. I actually have an existing Fargate cluster. So this is a cluster that has a service. That service is running on Fargate. If I take a look at the capacity providers, the only ones here are Fargate and Fargate Spot. And so maybe the question is, well, how could I get this workload to managed instances? And so what I'm going to do is I'm going to switch back to my handy CloudFormation, and we'll make some updates. So this was all defined in CloudFormation to begin with. So you can see that I have my cluster that has my 2 capacity providers. And what I'm going to do, the first thing I'm going to do is I'm going to add a new capacity provider into the stack. So I'll do that. Now, an interesting thing about this new capacity provider that I've just copy and pasted in is I'm actually putting in some instance requirements. This is no longer the default capacity provider. This is one where I want to have some opinions on what managed instances schedules. And there could be lots of reasons why you want specific instances, but in my particular case, it's because I want some of the brand new Graviton 4 instances, and I also want the ones that have the high network bandwidth as well. So maybe my workload is doing an awful lot of data processing. It's sucking in a lot of data, and so it needs high network bandwidth. And I really like Graviton 4 for the performance there. So what I've done here is I said, well, managed instances, you can decide which size you want, whether you want extra large, etc. But it has to be from this instance family. Other things I'm going to do, I'm going to go in here and I'm going to say, well, my task definition, I'm just going to put a required capabilities of managed instances as well. This is where we'll just verify that the task definition has all the properties we need to run on managed instances. But fortunately, I don't have to change anything here. Anything on Fargate can run straight away on managed instances. I don't have to change any flags in my task definition. And then the final thing I'm going to change is on my actual service, I'm going to change the capacity provider strategy. Right now it has Fargate, and I'm just going to use that new Graviton capacity provider that I just pasted in. So if I hit save, and we'll go up and deploy it. Switch back to Bash and do an update stack. That'll go away and it will do all of those things. So the first thing we expect to happen is we expect to see a new capacity provider in the cluster. There it is. So there we go. We have not just Fargate capacity providers, we have our managed instance capacity providers. And if I click in on that, oops, a bit too keen on the click, wait for it to refresh. Give it a moment to create. And
that's all right.
It'll
yeah, while that's doing that, we had another question come in. Is that okay? All right, so here's the question. I got to go back up here a little bit. And I don't want you to leave this yet, so if we can't answer, maybe we can do this later. But we have the question, what integrations can be used with managed instances and more control? Does that make sense to y'all?
What do you mean? Sorry, do you mind expanding a little bit on the integration side?
Yeah, Mohammed, what we're looking at, I'm not sure we understand what you mean by what integration. So if you want to add that to your list here, or if you want to put that back in the chat channel, we'll see if we can answer more of that. And then we have Randall and Patrick Steger going back and forth, but I don't need to post that. So, all right, we have it. It's up.
Yeah. Yep. So now my service, if I look at the service, you'll notice that a new deployment has started. We are deploying a whole new 3 new tasks, and we're moving them over from the previous configuration, which had the Fargate capacity provider. Let me take a look. And now we're moving over now to the managed instances capacity provider. So that's like a deployment. That's how my workload is migrating. It's obviously migrating in place. So there's no downtime here. We're starting new tasks before we shut down the old tasks. So there's no user impact of this migration. It's just like releasing any other ECS service update. And if I look at the infrastructure, you'll notice, actually first I'll click on that capacity provider, which is not playing ball. Give that a real refresh. There we go. You'll notice that the instances are only allowed to those C8 ones that I had in my CloudFormation. And what that actually means is managed instances could only choose from this set. And if I have a look at what it's actually provisioned for me, I'll have a look. There we go. We got some C8 GN larges. So you can see how using like the instance attributes inside of a capacity provider, we can be more specific and restrict exactly what instances get provisioned for our workload. So in this case, we want Graviton 4, we want the high network throughput. We're able to do it. We're able to get our workload over there without any downtime just by updating the service.
All right, that is super cool. Now I have a question for you. I have to ask this. We'll pretend somebody else has to, but I'm going to ask it here. I haven't seen GPUs yet. Are you going to show me GPUs?
I can show you GPUs. Do not worry.
All right, I want to see GPUs because that's one of the things we get a lot, right? When we're out there, it's like, look, I need GPU for inferencing. I need to be able to do that kind of stuff. So I need GPUs, and can I do GPUs in Fargate?
Not today. So
exactly, and so I use the managed instances. So how would I do that?
Yeah, so that's a good question. So here we go to a third CloudFormation template, and this one it's going to be a new cluster. So I'm going to create it, and then I'm going to come back and explain it because
that makes sense.
A few minutes for the GPUs to get going.
And while you're doing that, I'm going to explain to everybody that yes, I recommended we use CloudFormation because a lot of people use that, but nobody tells Ollie what to do, right? It's not like Ollie says, "Oh, because Eric says that I'll do it." He agreed with me on this, so. And then I said we would call it SAM. This is AWS SAM you're seeing in action. We did have a question come in, said it's not really a question, but more of a comment. So I thought Jeff was going to join. I'm assuming you're referring to Jeff Bezos, which now it would be Andy Jassy. He was not available for this. Usually he joins me, but he had some other things a little more pressing, but I mean only a little bit more. So there you go. All right, back to you, Ollie.
Thank you. So the stack I've just deployed, we're creating a new cluster again. We don't have to create a new cluster for GPUs. It was purely just me like grouping my workloads together using clusters as namespaces. And I've created a new capacity provider. Now in my instance requirements, I've actually gone and put in some accelerator restrictions.
There we go.
I've said in this case, the instance types that you choose have to have an A10 NVIDIA graphics card. So this is the various models of the NVIDIA graphics cards, and I've said I want one with an A10, and I've actually kind of constrained managed instances and said only use those G5 instance families that have one GPU. So I put those constraints around my capacity provider really to restrict where my what's going to get provisioned. Because, for example, maybe this is an inference workload. I don't want it to start provisioning on P series or something like that.
Sure.
I can use this to restrict that down.
Yeah, one quick comment here. Like you can also put the exact instance type that you want. So, for example, if you want to use the new like fractional GPU instances, you can just say like G6F.
It's in the Graviton one before. You saw how I had the families in. Here, you could absolutely do the same for the graphics instances as well.
All right. Now, earlier in an example you and I did offline, you had just put NVIDIA there. So
I did.
Okay.
But I've gone to be a bit more specific. I was like, I want a specific card. I was thinking about it.
That's fair. Well, I was just curious. So you have a lot of wiggle room there on how granular you want to get. Look, I just want NVIDIA. I don't care what you do. Down to look, it needs to be A10G or this family. Or very specific, so that's very cool.
Yeah. So if I actually go in to like create a new capacity provider in the console, and I actually just show you like here, you can see all of the attributes that you can choose. So you can choose everything from like related to accelerator, like name of a number, manufacturer, chip name, the type. All of that is attributes that you can put in. And we'll take that into consideration when we make the provisioning. So whether that instance families we just talked about, whether that's like network bandwidth, or whether that's accelerators, you can really like dial in exactly what instances we'll provision. Or as I mentioned, you could just use the default one and let us worry about that. And therefore you don't have to worry about making sure you update this every time there's a new instance family release.
And I would harken back to like what Eric was just saying before about our GPU is supported on Fargate. So like this very screen, you can see the default mode is just like Fargate. You don't do anything. But if you want control, you can give us options and we'll find those instances or we'll launch those instances, including GPU based one, but it's going to be fully managed compute just like Fargate.
So cool.
So if I take a quick look at the actual workload I'm running, I'm actually just starting a deep learning container. But one of the things that I'm doing here is I'm putting in a resource requirement and I'm saying I need one GPU. And you can obviously decide how many devices you want to attach to this particular task. But in my case, I'm using one. So the same way that you have CPU and memory for the scheduler to use when it's scheduling, you can also have these GPU requirements as well. So it will find a instance that has a spare GPU and attach that directly to the task. So yeah, if I jump back to the console with a bit of luck, maybe that will be running. So I have a service, I have a task. And just to kind of show a little bit of completeness, I can actually use, what do I want to do? I want to click into the task, and I'm going to use ECS exec just to play with that actual container. So this is me getting a shell prompt directly into that container that's running on managed instances. So you don't get it.
This Cloud Shell.
This is Cloud Shell. It's using the new ECS exec in the console. And you can't get access to the underlying instances on managed instances, but you can still use ECS exec to get into the tasks. So here I have a prompt into my task, and like just for completeness, if I do like NVIDIA SMI, you can see there my NVIDIA A10. So like met my brief, it's running, all the drivers are there, the device is mounted into my task. All of that is taken care of for you. You just had to put that resource requirement into your task definition.
Sweet. That's super cool. All right. Well, I will tell you that we are at about an 8-minute warning. So do you think we can do one more demo?
Yeah. Actually, I have one more demo to show, a real quick one, but it's a little personal favorite of mine. It's one of the little project I've been playing with. So one of those comments I we got a lot on the Fargate side, was people that used to ask me like, hey, I want to use my CI/CD runners on Fargate. Like, and inside of my CI/CD pipelines, I want to build container images. And it's a common ask, like, hey, I want to use Fargate because I don't have to worry about the compute, but I want privileges to be able to build container images.
Right.
And now that managed instances supports privileged containers, we're able to do that. And so I just want to show for the last fun quick demo, I'm going to start a new workload. I'm going to start it on one of my existing clusters, but this is the task definition, and it uses DIND. And for those that don't know or not close enough with the Docker world, DIND stands for Docker in Docker. And this is where we're actually running Docker engine.
I'm going to be really honest.
Inside of a container. And the cool thing about running Docker inside of a container is that it enables us to then build container images. Like I would say, adding privileges to tasks is a security risk. So I wouldn't do this lightly. And if you are going to do DIND, Docker in Docker, then I would give yourself like a dedicated environment to run privileged containers. I wouldn't do it in your maybe production cluster. I'd create like a dedicated space for it. But it is a way for us to build container images. And so what I'm just going to quickly do in this demo is I'm going to create this task definition over here. And that'll go away and create it. And just to actually explain a little bit of what happens, I'm running two containers. The first container is going to run the Docker engine. And then the second container is called my CLI container, and that's going to do my Docker build. So I'm actually running two containers in a task, one running the Docker engine, one running the Docker CLI. And I'm actually passing the Docker engine between them and doing the build. So now if I start a task, let me grab my handy helper script again. I'm going to run a standalone one-off task. And you do that through the run task command. And I'm going to put it on managed instance MI cluster and MI cluster default capacity provider. And this is the sort of thing that your CI/CD pipeline will do, like GitHub Actions may do or Jenkins may do. it would fire a run task to ECS to build my container images.
We can do this from step functions.
You can do this from, yeah. Absolutely. And so if I now look in my tasks, you will see, oh, I've got 100 running. I've now got too many. Task definition equals dind. You'll now see this be created and actually build a container image on managed instances using privileged containers. Quick look at the logs. If I look at just look here in the CLI, you can see, and for those that have done a Docker build before, this is the output of a Docker build. You've got all the layers that's going on, and it's building my container image. It's just a nice way to prove that I think it's done already, and that task will now disappear. But it's just a nice way to say, well, we have privileged containers. If you wanted to use something like Docker and Docker on ECS, you can now do it for managed instances.
All right. So what's the, and I know we're short on time, but help. I mean, of course, I understand, but if somebody didn't, right? What's the advantage of that? Is this where we get into like eBPF, or is that what you said that, or is this where?
Yeah, that's definitely not. So yeah, so me using Docker and Docker is definitely one use case for privileged containers.
Okay.
Another use case that we get a lot is for people that want to put runtime security tools onto their instances.
Okay.
And so eBPF is a way for people to instrument instances and get more monitoring, alerting, and information out of the host. And so yeah, you can do that now in managed instances.
Even for network monitoring, not just for security agents. So like Datadog, for example, has universal service monitoring. If I remember correctly, like that agent, for example, uses eBPF.
Right.
You can
so like a partner, if you wanted to use a partner to get analytics and stuff like that, this is where this would expose that on, even though it's managed by us, you still get, again, the best of both worlds. So, okay. Very cool. All right. That makes sense. Well, man, we covered a lot of information. Ollie and Abhishek, I really appreciate you both joining us. I've been excited about this when we first talked about it. And of course, we've done some videos and some blogs and things around it. Abhishek, your team did a great job on this. Thank you so much for doing this. Even Randall was saying it's a great launch. If you don't know who Randall is, he was like one of the OG DevRel. Now he's over, I think he's C-level or running the joint at Kalent. I don't want to say that, but he's a great guy, very smart guy. So good feedback. That's high praise. With that, I want to say thank you to both of you. Any shameless plugs you want to throw out in the last minute we have here?
Shameless plugs. The only thing I was going to say is reInvent is coming up. There's a whole load of managed instances content at reInvent. So if you're going to reInvent, or you want to check out the on-demand content afterwards, there's a lot of ECS. There's a lot of managed instances to look forward to.
Yeah, there's event-driven containers. So, good, Abhishek.
Yeah, like I was just going to say that, we really appreciate, and we always look for customer feedback. So excited to put this in front of customers. We also have our roadmap on GitHub. It's public. So if you run into any issues, if you have feature requests, or if you want to see our roadmap, please take a look, and we'll link the roadmap when we publish this. If you could do that, Eric.
All right. Sounds good. All right. With that, I'm going to try to get I don't know if I'll get that link in time here because we need to shut down, but I will post it on my social. So we'll do that. And with that, we're going to have to sign off. Ollie, thank you. Abhishek, thank you. And especially for everybody who attended, thanks for watching. And those who are watching later, we'll see you later. Bye-bye.
Thank you very much. Bye.